Reversing the sins against our soil, the evolution in how we view soil. You know, soil is the most valuable asset we have. It's right under our feet. It's a living organism. And it seems like we actually are starting to understand that. That's what we're talking about in this episode of the Business of Agriculture. Hey, Damian Mason here with a question before we hop into this episode of the Business of Agriculture. If you farm for a living, you employ a lot of amazing technology, from your inputs that you put into the soil to the tractor that you sit in, your combine, and the amazing data that it harvests. But has your soil analytics kept up technologically with everything else in your farming operation? I would venture to say that no, it is not. Sure, you check for your nitrogen, your phosphorus, your potassium, your micronutrients as well. But what about disease pressure? Do you know what diseases and what pests you're going to face next year? No, you don't. But you can now figure that out with Pattern Ag's predictive analytics. Think about it. They can tell you now with testing what the likelihood of facing nasty diseases, things like cyst nematode or sudden death syndrome, what the likelihood of you having this in your field. Then you know how to prepare, how to treat, and where to invest your money. It's using technology to make you bigger yields and therefore make you bigger money. Go to www.pattern.ag to learn more. They are pioneering the way in predictive agronomy. Hey there, welcome to another fantastic episode of the Business of Agriculture. You know, I'm so excited about this episode because I'm kind of geeking out here on soil. A little background, I was the 9th best soil judger in 1987 in the FFA soil judging national competition held in Oklahoma. I wanted to be an agronomist, but I went to Purdue. They handed me a biochemistry book and I said, maybe a little too much science here. So I do geek out about soil. I like discussions about soil. And what I really like is to see that we in the industry are starting to treat this ground it's selling for $15,000 or $20,000 an acre as the valuable asset that it is, but more importantly, as the living organism that it is. A guy named David Kleinschmidt with a company called Progressive Agronomy reached out to me. He's a listener, and he was talking about the evolution that he has seen from ag retail to today. You know, go out there and spray chemistry, you know, tons of synthetic fertilizer, to instead starting to understand, hey, wait a minute, maybe we should work with our soil versus against our soil. Maybe some of the stuff we were doing before was really good for selling product, not necessarily all that good for treating the soil the way it needs to. David is my guest today, and he brings on one of his clients from Southern Illinois, a guy named Mike Imhoff, who's a farmer. Mike, thanks for being here. You've been working with David for how many years? Since 2010, I think you said?
Yeah.
Tell me about your operation.
We farm about 1,300 acres. It's mostly corn and soybeans. My cousin does graze a few fat cattle for local consumption, so that about covers that.
David, tell me about your journey here, because you were excited to tell me about this, and we're going to talk about some of the neat things you're doing in way of reversing the sins against our soil. You're an ag retail guy. You're an agronomic guy. Take me from high school to now in 30 seconds.
Yeah, so in 30 seconds, that's pretty short. So I graduated high school, went to Southern Illinois University at Carbondale with an ag econ degree. Really focused more on the farm as a business more than anything in college. After college, I worked ag retail for about 8 years and had an epiphany moment halfway through those 8 years of starting to work with some cover crops and watching a lot of YouTube videos, and then started to go back and dig into some of those biochemistry textbooks and biology textbooks and try to understand a little bit more about the soils, and discovered there's a lot that we don't know, and just trying to, I guess, put the pieces all together from a biochemical physical stance.
So when I say reversing the sins, obviously, I tell this to anybody that maybe when I'm living in my winter home in Arizona and they say, you know, I just think this modern agriculture is really, I read a thing, I saw a thing on, there's always this misconception, if you will, that somehow the old days were wholesome and that everything was good and hunky-dory, and somehow what we're doing now on these factory farms is evil. And I say, oh, you mean like the wholesome, wonderful times of the 1930s? Would that have been a wholesome time when 3 states in the plains basically blew 500 miles away in a thing called the Dust Bowl? So starting just with that basis, what we did in the old days was not necessarily agronomically sound. Now, we did do more things like oats and hay fields, and we used manure, and those kind of things were good. But there's a return to some of that understanding. And I'd say that the thing that excites me most is probably in the last 5 years, I've seen this understanding about soil health that we didn't see. I'm 54 years old. I don't recall seeing it this much wide scale growth or evolution or belief. You know what I mean? I don't think it's still practiced. I think we're still here beating the hell out of our soils in many places. But you tell me what you think when you looked around about getting it. You said that when you emailed me that we're starting to get it.
Yeah. So when I look at soils, initially it was just a chemical stance. How much NP and K did it take? What's our sand, silt, clay compounds or components of our soils? And there was never really any focus on the biology part of it. And even today, I think we only know less than 1% of what actual microorganisms are in that soil and what they do. There's DNA metagenomics testing that we can do now and identify a lot more than even what we could probably 5 years ago in our soils. But every time we extract that soil out of its native system in the soil and run it to a lab, we introduce oxygen to it. All those microbes change, things happen in that soil. So we really don't know all of what's there and what they provide to us and what they do or don't do, so that's kind of the interesting and the fun part of all of this is trying to understand how to get some of these microorganisms to start functioning again, to start releasing some of these organic nutrients that are in that soil profile to start feeding our cash crops and what really like cover crops or even some of these other biostimulants and stuff that are out there that we could use to help stimulate that soil and get it to become more active. And really the thing is building aggregation in that soil and getting that soil to have more porosity to it and stable.
Mike, give me your evolution since, 10, 20 years ago about how you view, how you treat, how the practice you do with your soil. I'm assuming you're on here for a reason because David wants to use you as a poster child of one of his great clients. So what are you doing?
Poster child, huh? Yeah, well, we were full tillage. We were, chisel plow in the fall, field cultivator in the spring, fertilizer, 1.1 pounds of nitrogen for a bushel of corn. We were it. And in these hills, we was washing it all away. We were losing soil. So, I remember my grandpa, he grew corn behind red clover without much fertilizer added, and he grew a crop, but grandpa had a pretty good rotation too. So we've got back to the thinking that if we can add that clover and a little bit of a rotation here and use the covers for most of our nutrients and then supplement it with commercial fertilizer with what little bit we need and hold the soil in place and build it better, a little more organic matter and hold a little more water, it might work. And now we're a few years into it and it sure does work.
So you just described cover cropping and reduction in tillage. Essentially, those are the things you decide to do. You cut back on tillage. No more fall tillage at all?
No.
Okay.
A little bit of subsoiling, no-till subsoiling in some tight spots, but that's it.
Okay. So essentially you've gotten rid of all fall tillage. What about spring tillage? You still do some spring tillage?
No, sir.
Okay. Then you switched over to a no-till system pretty much. And then cover cropping. You mentioned clover 2 different times. You talked about your granddaddy. That's one of the things we use for cover cropping. Tell me about your cover cropping methods and what you're using and how you go about doing it. By the way, let me give the listener a little perspective. We're recording this on October 20th. So presumably you're just about done with harvest where you are latitudinally?
We're about halfway through it.
Halfway through. So after the combine's passed, then what?
we're drilling our covers now, and we drill all of our covers with a no-till drill. We design our covers for what we want out of them next spring. If we're going to corn, if we're going to soybeans, maybe the type of soil, if it's wetter, if it's high ground or if it's lower ground, and we design those covers for what we want out of them or what they have to do next spring.
So give me a sample of what you're putting out in that drill behind the combine right now. Clover.
Right now, we're drilling right now behind soybeans in preparation for corn next spring. So it's a hairy vetch, crimson clover, triticale, cereal rye, and radish mix.
There's a guy named Gabe Brown. You may be familiar. He wrote the book Dirt to Soil. I read it 4 years ago, maybe 5. I've heard him speak. I've actually had him on this show, The Business of Agriculture, and we talked about his journey to regenerative. And I'm hearing some of these same things that I don't think that Mike Imhoff calls himself a regenerative farmer, maybe per se, but that's what you're talking about. And utilization of 4 or 5 different species in your cover crop mix. There's this idea that if you just put one thing out, that's better than nothing. If you just put cereal rye out, that's better than nothing because you're protecting the soil, you're putting in the roots, you're creating some porosity, all those things. You put out 4 or 5 different things. The benefit there is they work even like synergistically to create a bigger outcome. Is that what you're seeing, Mike?
Yeah, each plant's got its own root expression and how it grows on top. So they all offer something different, and that's what we're after. I mean, we're not just feeding the corn next year, but we're feeding the microbes and the soil biology this winter also.
Tell me about how they all work together to create a bigger outcome, David.
Yeah, so the interesting thing is all the universities have tried to study like each individual species, and they look at just very simple things basically. But when you throw them all together, they all act a little bit differently. They try to compete with each other, but they also are very collaborative with each other as well. So like mycorrhizae fungi, it helps to connect out different plant species to each other and help to share nutrients. So we're looking at, like Emmy's operation there, he's got, 5, 6, 7 different species in a mix sometimes. And so we're looking at each one of those plants are releasing a different root exudate to feed a different microorganism for its nutritional needs. So if that crimson clover is needing zinc today, well, that triticale might need boron or something. So those plants releasing different exudates, feeding different microbes in that soil, and it's helping to build that more complexity, diversity into that soil system. So I say there's so much we don't know about it, but we do know that by adding more of that diversity into that soil system, the more aggregation that we build into that soil and the more resilience we build into that soil as well.
What about the different testing? You sent me some of that. We can talk anecdotally, but it's not just anecdotally because there's actually testing. You talked about metagenomic testing. I don't even know what that is. What is metagenomic testing?
Basically, it's a DNA test of the soil, of the microbes in the soil. Okay. It's not cheap test. It costs about $300 a sample.
Okay. So, and you've got, I'm sure you're going to get pushback. There's going to be people say, I don't need my soil DNA tested. I mean, hell, we've only been doing the fertility testing for like 50 or 60 years. So, and some people still don't do it.
Yeah. So I have a saying that I use with almost everybody that all soil tests are wrong and some are useful. And I don't care where you live. That's just a fact.
All soil tests are wrong and what?
Some are useful.
Oh, okay.
Yeah. So the cool thing about the metagenomics test too is not only looking at different microbes in that soil and their ability to help cycle some of the other nutrients that are in that soil, but it also looks at like different ones that are actually pathogens. So maybe it's Fusarium, maybe it's Phytophthora, things like that. So you can get a snapshot and say, hey, this field has a high or a low pressure of these diseases potentially in here. So how do we manage around that? But some of the other soil tests I do, I use the Haney soil health test, and I use that to kind of it's mimicking what that plant is actually releasing into the soil. So when we're sitting here and looking at like a Malick or a Bray or an Olson soil test, typically we're using some pretty harsh acids that soil never sees. But the plants actually release out these weak acids that are highly buffered that feed these microbes. They're basically carbon compounds or sugars, right? Mm-hmm. And so they feed microbes these weak acids in exchange for nutrients. So the Haney test is using 3 of the common root exudates, basically, that all plants release, and water as an extract because it happens to rain water in nature. And a lot of people, that's tough for them to understand because water alone is really hard to measure nutrients in that soil. But when you use it with the extractants and measuring the biology in that soil, now we can really start to see a snapshot of today of what can actually be released out of that soil and be taken as a credit. So I use that soil test to help determine how much fertility a guy needs for whatever cash crop, but I also look at the CO2 respiration, the microbial activity of that soil to determine, how much carbon that farmer can actually put out there without having a tie up of nutrients ahead of like corn. When we start looking at carbon to nitrogen ratios, a lot of guys, the simple thing is go out with cereal rye. If you go out with cereal rye in front of your corn, your soil respiration rate is at a 40 or a 50. It's low enough that, that next year when we go to put nitrogen out to that corn crop, the microbes are going to tie it up because they have all this carbon matter out there. They're not that active. So we got to build that microbial activity in that soil. And the way to do that is with more of the legumes, with more of the low carbon and nitrogen species. So I use that kind of as a tool and a barometer to figure out where I need to go.
By the way, what is it? The test to discover that? That's where you're talking about the Haney test?
Yes.
All right. By the way, Mike, I want to go to you, the farmer. When's the first time you started even hearing about the carbon to nitrogen ratio or its importance? Because this is probably in the last 2 years that I started hearing about it with my work with Extreme Ag.
Probably 2015, and I was like, "What is that?" And how's that come into play? And then we started pulling our tests in the spring and seeing where we were at, and knowing what we needed for nitrogen and how we were going to go about getting it. That's where it come in. The
soil testing historically, probably starting in the 50s, 60s, and some people still don't even do this, NPK. Then we started saying, okay, what about your micros? What about your boron, your zinc, your, those kinds of things. And now we're talking about, David here's talking about an entire list of stuff that wasn't even on our radar 5, 6 years ago, 10 years ago. Mike?
Yes. Oh, go ahead.
Oh, well, here, Mike's thought about this. Are you looking at stuff you didn't even look at 5 years ago?
Absolutely.
And
we're pulling biomass samples in the spring to know where we start at for nutrients. I never thought I'd do that before. It's hard to pull a biomass sample off of bare dirt.
Yeah. So you pull a biomass sample with living plants in it.
Yes, we pull a biomass samples in our fields every spring before we get started, and send them into the lab. They give us a report back that shows all the nutrients in that biomass. So we know we're starting our program, our nutrient program, with that right there. We're going to have that much to start with, and then we take a Haney soil test to see what we have in the soil, and then we amend our program with commercial fertilizer to fill in what little we have to have that we don't supply ourselves.
That, of course, is the simple answer. You've cut back on synthetic fertility inputs and expense significantly. Yeah.
Yeah, I'd say significantly. Yeah, I'd say, we're not putting on much potash, very little phosphorus anymore. And I probably don't put on 125, 30 pounds of nitrogen for our corn.
125 pounds of nitrogen, as you stated earlier. The rule of thumb used to be you need 1.1 pounds of nitrogen per bushel of corn that you expect to raise. Well, you're not growing 125, 130 bushel corn down there. So you're using like half a pound of nitrogen per bushel of corn raised?
We're coming out somewhere around 0.65 to 0.75.
Yeah. And it's just, and that's fine. I mean, you're not depleted. It's not like, oh, this is only going to work for a day. You're using up the bank. No, that's good. That's just sustainable.
Absolutely, it's sustainable.
Money. Do you have people that are your farmer buddies or neighbors that are still telling you this won't work?
No, they don't physically tell me that, but I know they're thinking.
But it is working.
Yes, it works. Yes, it works very efficiently.
David, you told me before we started about a bunch of different tests. So again, the evolution, and that's what I'm excited about. I want to hear about the evolution and how you're seeing some of this stuff work. Before I do that, I want to remind the listeners, if you are a farmer and you need answers, you have the phone, you have this thing in your pocket, you carry it around, you use it every day. Are you using it to your best benefit? There's an app called AgVisor Pro. I'm wearing their hat right now, AgVisor Pro. It's not like Twitter. It's not like where you're going to go in there and have a bunch of know-it-all dumbasses try and, ridicule you if you have a question. It's a bunch of people just like you that might have an expertise in something, like David Kleinschmidt, for instance, might be on there. And all of a sudden you say, hey, I've been looking around at this whole Haney test thing. Can you tell me how it works in practice? And all of a sudden you'll find it on AgVisor Pro. It's a whole bunch of information and experts and people like you that just want answers on AgVisor Pro. Put the app on your phone, AgVisor Pro. It's free. Put the app on your phone. Now then, PLFA. What the hell's PLFA? Total nutrient digestion. How do you do these tests and what's it mean?
So a lot of times with the PLFA, the Haney test, TND, total nutrient digestion, when I take a sample, I submit it all in the same bag, and the lab, can use that same sample that I submit to run all of those tests. The PLFA, the phospholipid fatty acid test, all of those microbes and everything have fatty acid cells. Yep. You and I have fatty acids, so it's just looking at like the different bacteria in terms of gram positive, gram negative, looking at ones that either feed on new carbon or feed on old dead residue, right? And it looks at the fungal component of the soil and looks at, the fungi that feed off of living plants or beneficial for living plants, or the ones that are decomposers. And then you have your saprophytes or your protozoa, that are kind of like the coyotes of the soil that eat the bacteria. And, what comes out the back end is basically plant available nutrients. So that's a test that we run sometimes every 3, 4, 5 years, just to kind of benchmark where we're going with things. The total nutrient digestion test is a look at it. Basically, it's digesting out the organic and the inorganic nutrients in that soil profile. So we don't farm in a flower pot, but we test our soils in the depth of a flower pot, 6 inches. And even at a 6-inch depth, the standard soil test, the Bray, the Malick, the whatever, would look at the likeliness of having a fertilizer response based on that soil's supplying power of phosphorus or potassium. But if you look at like the Illinois Agronomy Handbook, the usefulness, reliability, and efficiency of those tests, like the phosphorus is only 85% reliable. The potassium is only 60%. You get into the micronutrients that you're talking about earlier, I don't even look at those mainly on soil tests because they're only 10 to 20% reliable. So I'm not going to make a lot of decisions based on 10 to 20%. I'm not going to go to the gambling boat and bet on red if I only got a 10% chance, Yeah, no,
that's what's really interesting, because I my perception is that we were better at the analytics than we ever have been. And you're telling me we're not?
We're still using the same testing methods that were developed 80 years ago. And we've got more modern technology in our tractors. Our phones have got more.
Right.
can recognize my face and unlock,
Sure.
We're still in the same technology developed 80 years ago to determine how much fertility we need to apply to our soils to have a response in yield.
By the way, what's really interesting, since we talked about reversing the sins against our soil, and Mike and I went historic there and talked about what we constant tillage, 1970s, till, whatever, fence row to fence row, all that kind of stuff. And you just kind of nailed it right there in that some of our testing methodology hasn't evolved in 80 years when, for God's sakes, look at these tractors drive themselves and have 3 computer screens in them. So I think I'm getting onto something here. The testing that you're talking about doing then, is it just, what's the better way? What's the better method? Because the person out here listening to this says, well, what the hell am I supposed to do? What are my choices? And you're giving me a better method. So tell me the thing that Mike does, digging up a little bit of biomass in the spring. Is that the better method?
Yeah. So it's a whole systems approach, really. It's looking at the soil in the springtime of what's available at that time. How active are the microbes in our soils? It's looking at the total nutrient digestion, looking at the organic and inorganic amount of nutrients in that soil profile in the 6 inches, or we can go down to 12 inches even. And you'll see that there's 3, 4, 8 times more phosphorus and potassium in that soil and all other nutrients than what our soil tests actually show. So there's no way we'll ever mine our soils out. But how do we make that organic fraction become available?
Wait a minute. Are you saying that it's impossible to mine out a soil? Because that's been a common thing for a long time. People like me that are landlords, don't put a tenant on there. It's going to mine your soil out. It's going to deplete your soil. Are you saying it can't be done? Are you saying if you're doing what Mike's doing with a 6-way cover cropping during the winter and some of the practices, is it impossible to mine out a soil, period? Or if you're doing things the way he's doing it?
No. So if you're constant tillage and doing all of that, like you're spraying down a fall herbicide program to make sure no weeds emerge, and you're always, making sure nothing's out there. Photosynthesis drives this whole system. The sunlight energy feeds a plant. Those plants release 40 to 60% of that sugar it produces out through the root system to feed microbes. If we don't have that, all of that organic nutrients that are in that soil are not going to cycle. So yes, there we will, if we don't fertilize, we're going to significantly reduce those levels in our soil that are plant available because we don't have the creatures in the soil to make them available. Right. But I mean, there's some guys that don't hardly spread anything and they raise a pretty good crop. And really, when you go and look at like a sample, you take a standard soil test in a wooded environment, or take a fence row out and you sample that fence row that hasn't been fertilized or anything. That fence row will actually have lower values of P and K, but will out yield the rest of the field. Part of it is due to the carbon component that's in that soil, but the major reason is all those plants that were there were feeding a huge pool of microorganisms in that soil profile too. So you ride that wave for 4 or 5 years and then it all levels back out and it's like the rest of the field. So what my thing is, you talk about fence row to fence row. Well, I want the whole field to be that fence row, So let's plant something out there to feed those
minus the rocks and the old fence posts. You want the whole field. You want the field to resemble biologically the soil that's in that fence row. Mike, is that what he's saying? Yeah. Mike hasn't talked for a while. Is that what he's talking about over here?
Yeah, that's what he's wanting. You want to put the carbon back in your soil. You want to be able to store the carbon back in the soil. You've got to have that, and we've just burned it up for years and years. Every time we put a disc or plow in it, we burn it up.
Okay, so is tillage is it tillage that is the problem? It seems like that's what we're hearing. Tillage. Then,
well, that's some of the problem. That's not all of the problem. Some of these fertilizers are burning up also. Ammonia is pretty tough on soil, but it's a cheap way to get nitrogen. So we use it.
Yeah. Okay. So about the carbon thing, because there's supposed to be carbon programs, right? I mean, True Terra is one of my sponsors of this podcast, and they talk about the carbon thing. If I just put in cover crops and reduce tillage, and I get some money, let's say, to do so from a government program or from something through like Truterra, do I then get the carbon that I need and then everything's hunky dory?
It takes a long time to build that carbon in the soil. Realize that just by no-till alone was kind of a faulty practice of looking at building carbon in the soil, because 85% of that carbon that's in the residue leaves as CO2. So it's not actually going back into the soil, whereas the living roots will put that 85% back into the soil.
Okay, so no-till is still good for a reduction of erosion, but it doesn't necessarily cycle carbon until you put in a secondary crop, meaning a cover crop that's a non-harvesting crop is what we cycle the carbon with.
Yes, correct. Yeah. And there's really no consistent means of measuring carbon in the soil. Now, I worked with a project out in Kansas, and they were doing some 3-foot soil cores and sending them off to Mizzou and actual carbon dating those soils, which was pretty cool, because you start thinking about your soil, it's kind of like the rings on a tree, and it can tell you everything about what crop was planted and different tillage practices or whatever throughout the years. So carbon dating soils is really cool, and seeing how much carbon's been stored and how deep that carbon is stored into that soil profile. Because then we can compare, that top 12 inches to 3 foot down to compare all of it.
Yep.
But there's no consistent measurement from the East Coast to West Coast, north to south, So, that's one of the faults of a lot of the carbon markets out there and everything is based on a model. And some of them are even saying, well, they'll pay more for no-till than they are for the cover crops themselves. And I don't know, I kind of go back and forth on that, because you can't expect a 2,000 acre potato farmer or a peanut farmer to do no-till. Tillage just happens to be part of that practice of harvesting that crop, you know. But right. You talk about the sands, are you doing potatoes and peanuts every year, or are you doing that every 4th year or 5th year, and you use cover crops and different diversity in between that cash crop so that you can help remediate that soil profile there? But there's some programs out here, the 45Z tax credit that's was introduced in the Inflation Reduction Act bill for the
wait. Before we get in the program, I want to go back to one of your previous things, and then I want you to explain the program. What you also described right there, if you're doing potatoes and potatoes, monoculture is something that, by the way, the environmental people don't like about modern agriculture is they talk about monoculture, but it's not really monoculture. If Mike has, after soybeans, puts in a 6-way cover crop mix, he's just changed the whole nature of that. It's monoculture is bad. Beans after beans after beans, peanuts after peanuts after peanuts. We deplete the hell out of the nutrients. We introduce parasites generally, right? And then you need, corn on corn on corn. If you, am I right here, Mike? Then you need a shitload of new chemistry to kill off new parasites. Am I right?
Yeah, disease, it can be bad, but yeah, I mean, it just starts snowballing when you just do that, when you don't change anything. I mean, our soil can get used to our cover crops. We change our cover crops every now and again to be able to keep our soil rolling. We don't plant we're not the same mixes for the same crops every year for that reason.
Just because then it becomes the same problem as with a monoculture.
Absolutely.
Okay.
That's right.
Programs, David, you were getting ready to tell me about that. So I wanted to make sure that we were discussing, to the person that's not soils oriented, they're going to say, like, well, what's wrong with that? Well, what's wrong with it is the things we just said. The same crop after year, or even the same cover crop ends up introducing some parasites and also depletion. Programs.
Yeah. So the Inflation Reduction Act put this 45.
Some of us call it the Inflation Creation Act, but yes.
Yeah. I'd agree with that. So this 45Z tax bill is basically a tax credit to the ethanol and biofuel industry. So you think about it, almost 40% of our corn that we produce in this country goes to ethanol.
Yep.
Okay. So in order for an ethanol plant to receive this tax credit, they have to purchase low carbon intensity corn, because they have to be able to get this tax credit. They have to lower their emissions, or their carbon intensity score, which is
Right.
measured through the GREET model that was developed by the Argonne National Laboratory. But they have to lower that below a 50 to be able to get any type of a credit. And since corn makes up 29 points of that 50, so a farmer like Mike, who is using cover crops and reducing his nitrogen, but maintaining or increasing his yield, he could have a CI score on his corn instead of a 29. He might have a 10 or a 5, or it could even be a negative number. So how this works is a bushel of corn produces about 2.8 gallons of ethanol, right?
And, I've actually never heard that before. I knew there was an equation. One bushel is about 2.8 gallons. Okay, thank you.
Yep. And so you look at that, and the ethanol industry will get 2 cents per CI point per gallon. Okay, so if you do the math on that, that rounds up to almost 6 cents per bushel per CI point. So you look at some of these programs that are out here at $10, $15 an acre. Let's say if Mike's score was at 13, and he raised 200 bushel corn, he would have a value for his corn to that ethanol plant would be worth about $190 an acre. But he has to have the data to be able to manage that. And so I'm working with companies that help to manage some of that data as well.
What'd you just say on his field? What'd you say the carbon intensity, what'd it be worth? On 6 cents a bushel, I just ran 6 cents a bushel on 200 bushels. That's only $12.
Per CI point. So take 29 to 13. Okay, that's 16. So 16 times that 5 or 6 cents times 200 bushel.
Oh, okay. Okay. So I had the 6 cents. So I had the 6 cents per bushel, and then I didn't have the other thing. What's the other thing? Where did the 16 come from?
Yep. It's the difference between the corn's national average at 29 and whatever the score would be.
Okay.
So how that's measured is if you go and you're doing strip till, no till, ridge till, I don't care, a minimum tillage type system, if you're using a cover crop, if you're better managing your nitrogen, phosphorus, potassium, if you're able to be a better manager and use less but maintain your yield is your common denominator of the whole equation. So you want to be able to either maintain your current yield at or above the county average. So there's no use of cutting back. If your county average is 200 and you raise 130 bushel corn, that's not real efficient, right?
Right.
So we want to be able to maintain some pretty good corn still as well, and soybeans as well. I mean, this biofuel thing is going to be huge. Even with you look at soybeans and being able to make sustainable aviation fuels and stuff. So soybeans could actually be worth more. Now, this tax credit goes into effect January 1 of 2025. They're still writing the tax bill on it, so we don't know all the language of how much of this is going to be worth, who's going to get what percentage of the pie here. But the crop that is produced in 2024 will be sold to the elevators January 1, 2025. That's when the 24 crop is going to be supplying the ethanol and biofuel industry in 25. So a farmer needs to be thinking about right now this fall what they can do to start lowering their carbon intensity, whether it's better nitrogen management, using different tillage practices, maybe trying a cover crop or something, reallocating. That's one of the things that me and Mike talk a lot about.
Wait, I want, before we get into what the practice we can do, let's talk about the money part of it. First off, how much is this going to end up being? How much does Mike end up standing to make? If a bushel of corn's $5, let's just say, does he get an extra 50-cent bogey because of his carbon intensity index?
Unfortunately, we don't know the answer to that yet.
Okay. So I don't know that a lot of farmers are going to make any big wholesale changes until they have a little bit more to go on. I'm not being skeptical. And I'm not even the farmer, but if I were, I would say, well, I'm not going to make any wholesale changes. Hell, this could be like for 2 cents. I'm not going to make big wholesale changes for a potential 2 cents. The other part, and Mike's nodding his head right there. What would you do? How much is it going to take to make you make a big change? You're already making the changes.
I'm already making the changes. So what I'm doing, I'm going to keep doing. But, my true feelings are the farmer won't get rich off of this. You want to know the truth? Most of it will be doled out before it ever got to the farmer. That's usually how it works anyways.
You mean like the processors?
Every one of them, as it comes down, we're at the bottom of the chain. And by the time it gets down to us, most of it's usually gone.
All right. By the way, a few of us might say, well, wait a minute, that's not necessarily true. Go to the USDA and there's still programs in there that you guys, isn't that why your hat's shaped like that? Putting your hat in the mailbox every day to see if the check showed up.
Yeah.
Hey, here's the thing that I want to ask about. Who the hell's going to monitor all this? Let's say I'm out here just tilling like nobody's business. I fall till my soil blows away and I still take my corn to the ethanol plant and I get the same program as Mike. Is that going to happen?
It shouldn't. The bushels may have to be regulated on basically different companies have different models out there right now. Well, it's all the same model, but they have a system that you can enroll every one of your fields in. There'll be a field by field system that's that basically your bushels that are produced on that field will track with it. No matter if you sell it to a local elevator who then sells it to an ethanol plant, those bushels can be contracted direct to the ethanol plant. There's
supposed to be a tracking method in place, and all of a sudden now the practices we're talking about already make sense. Mike didn't do these practices because of some Inflation Reduction Act. He did these practices before the senile puppet was even in office, before there was an Inflation Creation Act. Sorry, I got a little political there, Mike.
My whole thoughts on this whole thing is, if we're wanting to if this whole thing is about carbon and we're really wanting to lower the carbon emissions, instead of paying the third part or paying the ethanol and CPGs of the world out here, let's pay the farmer directly a tax credit. Let's do away with CSP. Let's do away with EQIP. Let's do away with all those programs, put all that money into a tax credit that goes right directly to the farmer. And then you'll see a change happen. But we don't know how much. Every hand that touches this tax credit is going to take a penny or two out of it, right? So
I think Mike already said that. And by the way, if you thought that the programs were really about changing the weather versus just doling out money, I think that you're probably naive. Does that sound accurate, Mike?
Yes, perfectly.
Okay. Let's get back to the sins against the soil. Now that you've gone down this whole political role, nobody wanted to do this. David did this to us, Mike. You and I are just sitting here happy as a lark, and he starts going down this political. Hey, let's talk about then. Get me out of here. I want to reverse the sins against my soil. Tell me what I need to do and why I should do it. I think the first thing we're going to hear is obviously erosion control. Mike's going to tell us that, the hills were washing away. So the reason to do it is that. What do I need to do? Tell me the first thing I need to do. I want to reverse sins against my soil.
Keep it simple. I think too many times guys see all the pictures online. They hear all this really big success stories and they go too far, too deep, too quick. A simple oat and radish, a head of corn, something that winter kills out and is easy to manage into would be great. Understanding carbon to nitrogen ratios is probably absolutely critical. You had mentioned a book by Gabe Brown. I know Gabe very well, but there's a book that I recommend to everybody. When you go and buy a new lawnmower, you get an owner's manual. You buy a drill, there's an owner's manual in it, right? But there's no owner's manual on the soil. You talked about, ninth on your soil judging and everything, but did you have a manual that actually described every part of the soil, or just looking at the horizons? Right?
I own three farm properties, and every farm property, and I didn't inherit one of them. So the ones that I bought, they never came with an owner's manual. You're dead on accurate about that. And you talked about the first things to do. Okay, reduce tillage, I think, is probably going to be one of your first things to do, right?
Yes. I mean, I'm not saying that a guy has to go no-till. And I'll tell you why. One of the reasons is, especially to corn, tillage alone releases 30 to 50 pounds of nitrogen in the spring. So that if you're going to no-till, you gotta figure out how to put 30 to 50 pounds of nitrogen up front to make sure that crop visually looks like the way you want that crop to look. And it takes a lot of patience too. But there's a book called A Soil Owner's Manual by John Sticka. It's written at a level that a sixth grader could understand very easily. It's on Audible. I would highly recommend that to anybody to listen to, and just to understand soils, carbon to nitrogen ratios, and a little bit about the biology.
A soil owner's manual.
A soil owner's manual, that simple.
All right. That's your recommendation. Cover crops, yes. More than one species. What's your recommendation to somebody that wants to reverse sins against their soil, Mike?
Don't get over your head. There's a lot of things you can do that you don't have to do. Don't think you're going to come in your first year and plant corn into 2 tons, 3 tons of green biomass and think you're going to be comfortable and it's easy peasy. Don't set yourself up to fail.
Okay. So you dipped your toe in. You dipped your toe in before you went full tilt.
Absolutely.
On the cover cropping. Got it. All right, get me out of here, David.
Well, one other thing I would say is try to develop some peer networks within your area. There's probably farmers who are doing them in your area. Don't reach out to somebody that's 200 miles away. They can be okay to learn from a little bit, but you have to adapt. Don't adopt anybody's system. Adapt it to your own management.
Yeah, that's a good one. And actually go with someone that's doing it and having success with it.
Yeah. Don't go to the guy that's making 130 bushel corn in a 200 bushel environment.
I think we're going to go and close it out right there. His name is David Kleinschmidt. He's a company called Progressive Agronomy, and he's a fan of the show and also now been on here. I think I'm going to have him back in another couple of years. We're going to talk about the continuing evolution on how we view these soil things. I know that we could have talked more, but after all, let's save it for another episode when we can get into more of where this thing goes. I think 2 years from now, we're going to know even more. Am I right in saying that? 2 years from now, all of a sudden, Mike's going to have a different story about something he tried that you brought up, a new test, right?
We hope.
Mike Imhoff, Murfreesboro, Illinois. Have a safe harvest, my friend.
Have a good one.
Thanks for being on here. Until next time, I'm Damian Mason, and this is The Business of Agriculture. Hey, thanks for being here. This episode of The Business of Agriculture was brought to you by Pattern Ag. You've heard me talk about Pattern Ag because I think it's a pretty cool concept. New technology that allows you to predict the problems you're going to have and therefore treat them before those problems cost you money. What kind of problems am I talking about? Pests and disease. Things like cordon rootworm, sudden death syndrome, cyst nematode, and a whole bunch of other bad things that happen out there in the field that can cost you money. Guess what? Pattern Ag will let you find out ahead of time if the disease or the pest pressure is there, and therefore you're treating it before it costs you any money. What a great concept. Go to pattern.ag, that's www.pattern.ag, to learn more about their product, their technology, how it can make you money, save you yield, and also where you can find a rep that can come out there and do the work for you. Pattern.ag.